Today we are going to learn about mastering grid search for hyperparameter optimization. We'll focus on setting up and executing grid searches to fine-tune machine learning models for enhanced performance and accuracy.
Welcome to our session on mastering grid search for hyperparameter optimization. In machine learning, tuning the hyperparameters of a model is essential for achieving optimal performance. Grid search is a systematic way of working through multiple combinations of parameter tunes, cross-validating as it goes to determine which tune gives the best performance. It's like setting up a grid of possible parameter values and testing each one to see which combination works best for your model. Today, we'll dive deep into this technique and learn how to implement it to enhance your machine learning projects.
Before we delve into grid search, let's understand what hyperparameters are. Hyperparameters are the external configurations of a machine learning algorithm, in contrast to model parameters which are learned from the training data. Examples include the learning rate for training a neural network or the number of trees in a random forest. Unlike model parameters, hyperparameters are not learned during training but set prior to the training process. The right choice of hyperparameters can drastically improve your model's performance, making their optimization a critical step in the machine learning pipeline. Hence, mastering techniques like grid search is invaluable. Now that we know what hyperparameters are, let's talk about setting up parameter grids. A parameter grid is essentially an exhaustive list of hyperparameter values to test. When constructing a parameter grid, it's crucial to include only those parameters that substantially affect model performance. For instance, if you're working with a support vector machine, you might include the C and gamma parameters. However, the more parameters you include and the more values you test, the larger your grid becomes, which increases computational cost. Therefore, you must balance between a comprehensive search and practical limitations. We'll look at practical examples to understand this better.
One of the primary challenges when setting up a grid search is finding the right balance between thorough exploration of hyperparameter space and computational feasibility. A comprehensive grid search can become computationally expensive, especially with large datasets and complex models. Some strategies to reduce computational cost include narrowing down the range of values for each parameter based on domain knowledge or using a randomized search to sample a smaller subset of the parameter space. Understanding these trade-offs is essential for efficient hyperparameter tuning. We'll explore how to implement these strategies in practice to ensure effective model training.
Scikit-learn, a powerful Python library for machine learning, offers the grid search class to facilitate hyperparameter tuning. To implement grid search, first, import the necessary modules from scikit-learn. Then, set up the parameter grid as a dictionary where keys are hyperparameter names and values are lists of settings to try. Next, initialize the grid search class with your model, parameter grid, and desired cross-validation settings. Execute the grid search by fitting the model on your data. Once complete, you can access the best parameters and score using the best_params_ and best_score_ attributes. This process allows you to systematically find the best hyperparameters for your model. Cross-validation is a fundamental technique in machine learning used to assess the generalizability of a model. It involves partitioning the data into subsets, training the model on some subsets, and validating it on others. In grid search, cross-validation is used to evaluate the performance of different hyperparameter combinations systematically. You can specify the number of folds or use advanced techniques like stratified k-folds for imbalanced datasets. Choosing the right cross-validation strategy is crucial for reliable model evaluation. We'll delve into the best practices for cross-validation to ensure your model performs well on unseen data.
Overfitting occurs when a model learns the training data too well, capturing noise instead of the underlying pattern, leading to poor performance on new data. During hyperparameter tuning with grid search, there's a risk of overfitting, especially if the parameter grid is too large or the cross-validation strategy is inadequate. To prevent overfitting, you can apply regularization techniques or use simpler models. Another strategy is to use a validation set separate from the training data to evaluate model performance. Understanding these strategies will help ensure your models generalize well to new data.
Automating the grid search process can save time and reduce the potential for human error. By writing reusable Python scripts, you can integrate grid search seamlessly into your machine learning workflow. These scripts can handle large datasets by implementing efficient data processing techniques. To improve script efficiency, consider parallel processing or distributed computing resources. Automation allows you to focus on interpreting results and making strategic decisions rather than manually setting up each grid search. We'll look at how to write and optimize these scripts for maximum efficiency in your projects. To solidify our understanding, let's apply grid search to a real-world dataset. Suppose we're working with a dataset predicting housing prices. After exploring the data, we choose a random forest model due to its robustness. We then set up a parameter grid including the number of trees and maximum depth. Using grid search, we execute the search and analyze the results. We find that a certain combination of parameters yields the best cross-validation score. Finally, we evaluate this model on a separate test set to confirm its performance. This case study illustrates the practical application of grid search in enhancing model accuracy.
Congratulations on completing the session on mastering grid search for hyperparameter optimization. We've covered the importance of grid search, how to set up parameter grids, balance exploration with computational cost, and implement the process using scikit-learn. Remember, hyperparameter tuning is a critical step in refining machine learning models. As you continue your learning journey, experiment with different datasets and models to gain hands-on experience. Consider exploring advanced techniques like Bayesian optimization or automated machine learning. To further your understanding, check out additional resources and tutorials online. Happy learning and successful model tuning!